Good day, everyone. We are the Group 7, and today we are going to do a home lab activity about soil composition and its water holding capacity. Do you ever wonder what is soil made of? You may think that all soils are the same, but definitely not, because there are different kinds of soil, how they differ, and which component of soil hold the largest amount of water. Wonder no more because with this fun and exciting experiment, you'll be able to describe soil in relation to its composition and characteristics, identify the kinds of soil and compare their water holding capacities, and describe the porosity and permeability of soil. Now, what is soil? Well, soil is the loose surface material that covers most land. It is a mixture of different materials or substances. There are five basic components of soil that, when present in the proper amounts, are the backbone of all terrestrial plant ecosystems. These are minerals, water, organic matter, gases, and microorganisms. The combination of these determine the soil's properties, its texture, structure, porosity, and color. Mineral is the largest component of soil, which makes up approximately 45% of the volume. Water can make up approximately 2 to 50% of soil volume. Water is important for transporting materials to growing plants and soil organisms and for facilitating both biological and chemical decompositions. Soil water availability is the capacity of a particular soil to hold water that is available for plant use. Organic matter is the next basic component that is found in soils at levels of approximately 1 to 5%. Organic matter is derived from dead plants and animals and as such has high capacity to hold and do and or to provide the essential elements and water for plant growth. Gases or air is the next basic component of soil. Because air can occupy the same spaces as water, it can make up approximately 2% to 50% of soil volume. Microorganisms are the final basic element of soils, and they are found in the soil in very high numbers but make up much less than 1% of the soil. There are three basic soil types: sand, silt, and clay. Sand is comprised of tiny rock fragments and is the roughest in texture. Clay becomes sticky or greasy when wet and very hard when dry. Silt is between sand and clay in texture. Loam, on the other hand, is a combination of sand, silt, and clay and has a high proportion of organic matter. And now, Miss Vanessa will give us an extraordinary experiment to help us fully understand the different kinds of soil and its water holding capacity.
So these are the materials needed. We have three different types of soil: measuring cup, plastic cups, 3 cans, DIY hand lens, paper, cloth, and water. So we have three types of soil here. We have the sand, the loam, and clay. We also have 3 pieces of paper. All we have to do is to pour a small amount of soil on each paper. So, small amount. Then examine the soil samples using the DIY hand lens. We also need a ball pen as well as a paper to record our observation. Prepare 3 cans of same size by removing completely both of its lids. Cover one opening of the plastic cups with an old cloth and secure it tightly. So the old cloth will act as an alternative filtering device for the experiment. Fill each can with soil samples, one type of soil for each can. So let the can sit on top of plastic cups, then pour 250 ml of water to each can very slowly and observe how the water flows from the can to the jar or the plastic cups. So record the amount of water collected for each setup. You may use measuring cup for a more accurate measure. This is the volume of the pore spaces or the VPS. So for this experiment, it is advised we use 500 ml water. However, I compromise to use 250 ml of water due to the size of cups. So find the porosity of each soil type using the given formula. VPS divided by total volume times 100 is equals to percent porosity. Prepare 3 cans of same size by
Soils like sand, loam, and clay vary in many different ways. They differ in size, color, texture, porosity, permeability, and water-holding capacity. Soil texture refers to the size of the particles that make up the soil and depends on the proportion of sand, silt, and clay-sized particles and organic matter in the soil. Sandy soils feel gritty when rubbed between our fingers. Most clays are sticky and moldable. Loam soils contain sand, silt, and clay in such proportions that stickiness and non-adhesiveness are in balance. So, the soils are moldable but not sticky. Soil porosity refers to the space between soil particles. Porosity influences the movement of air and water. It depends on both soil texture and structure. For example, a fine soil like clay has smaller but more numerous pores than a coarse soil like sand. Sand has bigger particles than a clay soil, but it has less porosity, or overall pore space. Water can be held tighter in small pores than in large ones, so fine soils like clay can hold more water than sand. Whereas permeability is a measurement of how easy it is for the fluids to flow between soil. The permeability of material depends on how large the material's pores and how interconnected are the pores. Which means that if the pores of the soil are not connected, then the soil is non-permeable. Sandy soils are known to have high permeability, which results in high infiltration rates and good drainage. Clay-textured soils have small pore spaces that causes water to drain slowly through the soil. Clay soils are known to have low permeability, which results in low infiltration rates and poor drainage. And now, when we say water holding capacity, it is controlled primarily by soil texture and organic matter. In terms of soil texture, those made up of smaller particle sizes, such as in the case of clay, have larger surface area. The larger the surface area, the easier it is for the soil to hold onto water, so it has a higher water holding capacity. Sand, on the other hand, has a large particle sizes, which results in smaller surface area. Therefore, the water holding capacity for sand is low.
Through the discussion earlier, I hope that you've learned something. And for the conclusion, soil is composed of both non-living and living materials like plants and insects. Also, it composed abiotic factors, mainly the minerals, water, and the air. So, how does the water holding capacity helps the soil health? So, water holding capacity helps to retain the balanced amount of water to nourish any crops, as well as it helps to keep the soil organic matter alive. So, healthy soil structure forms into aggregates, lessening the density of the soil to create more pores. When the soil create more pores, it helps to filter water in and out. So, water holding capacity, as we've learned through the discussion, it is the amount of water in the soil. So, the amount of water in the soil. In addition, water holding capacity is the maximum amount of plant available water a soil can provide. So, it indicates the soil's ability to retain water and make it sufficiently available for plant use. Always remember that once you step out into a piece of ground, you step out onto something that is alive. Soil is not just a piece of dirt. Soil is made up of living and non-living things, as I mentioned earlier. So it is spread in a very thin layer and a surface we called earth.